Good day, students. Today we are going to start a new topic. The last class we finished conservation of momentum, collision, and center of mass. Okay. So today we are starting rotational motion. Rotational motion. Okay. Now this rotational motion is also known as rigid body dynamics. It is also known as rigid body dynamics. Rigid body dynamics. Okay, so first thing that we need to understand in this one is what is rigid body? What is called a rigid body? Rigid body is one thing in which the separation between any two particles of that rigid body cannot be changed. Okay, separation between any two particles of the rigid body cannot be changed. That body is called rigid body. Okay. Separation between any two particles of rigid body cannot be changed. Cannot be changed. Okay, now suppose that I make one body in this one, arbitrary, anything I can make like this. Okay, and I choose this point here, and I choose this point. Okay, point A and point B. This is a rigid body. So this cannot be changed. Okay, so with respect to A, with respect to this point A, what kind of motion this B can do when the separation cannot be changed? That means the distance between them cannot be changed. So what kind of motion it can do? Only one motion is possible. What is that? Circular motion. B can only perform circular motion above A. Right? Okay. If suppose another point is there, it's point C. Okay. So C also, if suppose with respect to A we are asking, C also will be rotating. It will also be in circular motion. And the interesting point is the angular velocity of B with respect to A and angular velocity of C with respect to A will be same, omega. Or for that matter, angular velocity of B with respect to C. Suppose with respect to C you are seeing B. That also will be omega. That is the property of rigid body. Okay, angular velocity of this point with respect to A or C with respect to A or B with respect to C. Everyone will have same angular velocity. So point number one, separation between them is fixed, cannot be changed. And then the second point is every point in this rigid body is going to have circular motion about other point, and its angular velocity will be same. Okay, this thing you keep in mind. This is the definition of rigid body. Okay, then what else is there? In rigid body, rotational motion it is. So, first thing that we saw in translatory motion. What is translatory motion? All these topics that we did before that were related to straight line motion, those are translatory motion. So, in translatory motion, if you remember, the first thing that I told you was inertia. Inertia was what? Opposition to change in state of motion. And state of motion was in translatory motion. Okay, inertia was opposition to start the motion, to stop the motion, right? Here also, because here we are going to talk about rotation. So here we are going to study inertia, and this inertia is called moment of inertia. Okay, what is moment of inertia then? Inertia of rotation. Inertia of rotation. That means this is the opposition that you are going to get while starting rotation or stopping the rotation. Okay? What is moment of inertia? Opposition to start the rotatory motion or stop the rotatory motion. In translatory motion inertia we studied. We said that mass is the measure of inertia. Okay, and there was mass was the measure of inertia. Then here, who's the measurement of inertia? We'll see that. What is the measurement of inertia? Okay. So moment of inertia doesn't depend only on mass, because for anything to rotate you require what? Radius also. So position of the mass about the axis, about the point where you are going to rotate, that is also important. So if suppose that this is how the body is, if body you have taken, and this is the body about which we are going to rotate it, okay, and here is some mass, let's say this is the mass m, okay, or you can take many masses over here, m1, m2, m3, okay, and the distance from axis of rotation r1, this is r2, and this is r3, right, and you are rotating them, let's say with angular velocity omega. Okay, we are rotating them with angular velocity omega. So what will be the velocity of this one? This one's velocity will be r1 omega. Its velocity will be r2 omega. Its velocity will be r3 omega. So what is the total kinetic energy? Let's see. Kinetic energy half mv square, what else? So kinetic energy of this total thing I am writing as half m1 v1 square plus half m2 v2 square plus half m3 v3 square. That's it. Right? Now, v1 is what? R1 omega. We have studied in circular motion, v equal to r omega, right? So, half m1 r1 omega square plus half m2 r2 omega square plus half m3 r3 omega square. Right? Further, this is half m1, this is m1, r1 square omega square plus half m2 r2 square omega square plus half m3 r3 square omega square. So what do you can write? Omega square by 2 I can take common. Okay? So half omega square I take common. This is m1 r1 square plus m2 r2 square plus m3 r3 square. And if suppose more masses would have been there, you could have, right? So in this one, this is what? Now you compare it with the normal kinetic energy formula. What is the kinetic energy formula? Half mv square and linear motion. This is velocity of center of mass. Okay, linear motion. So this is v. And what is omega? Omega is velocity in angular motion or rotatory motion. So let's compare. This is omega square, this is by v. This is v square by v. Now what is this m? M is the measure of inertia. M is measure of inertia. Now compare it with this one. V square by 2 here, omega square by 2. So this entire thing is actually measure of inertia. What is it? This is measure of inertia when you compare both. But this here we are calling as moment of inertia, and this we are representing with I. What we are representing this with? I. So here kinetic energy we are writing what? Half omega square into I. So what is I? We have written already. I is m1 r1 square plus m2 r2 square plus m3 r3 square and so on. Okay, this is moment of inertia. What is the unit of this? You can see that I can write this as in one formula. Total mass is sigma. Sigma means addition. Okay, mi ri squared, where I is equal to 1 to I equal to n. Okay, this entire thing can be written like this. I equal to, here what is, how many particles are there? 3 here. So I equal to 1 to I equal to 3. So what do you write? m1 r1 square plus m2 r2 square plus m3 r3 square. Right? This is moment of inertia. What is its unit? Kg meter square. Unit is kg meter square. What type of quantity is it? Is actually it is a tensor quantity, neither scalar nor vector. It's a tensor quantity. Okay, but suppose in the question it is asked from you, what type of quantity is moment of inertia. And in the options you don't find tensor, then you go for scalar. Go for scalar quantity because this is not at all a vector quantity. Okay, it's closer to scalar than to vector, but actually it is tensor quantity. Okay, so let's see then. We got the formula for moment of inertia. Okay, moment of inertia as such is very important topic. Okay, in rotational motion, if I say there are going to be 5 questions, okay, or 5 questions from rotational motion in NEET, okay, then out of that 5, there are chances that 2 questions or 3 questions will be related to moment of inertia. That much important topic it is. So you need to make it perfect. Okay. So let's see a few basic questions, few basic problems we'll do so that you are comfortable in moment of inertia. Okay, the first question I am asking you. Okay, so here is axis of rotation. I have one particle here, 2 kg, and this separation is 0.1 meter. Okay, here one particle is there. It says 0.5 kg. And this is given as 0.5 meter. And I want to find moment of inertia. Total moment of inertia of this system. Right? So, okay, I we have to find, and I is what? Formula says m1 r1 square plus m2 r2 square. Now, is this r is always perpendicular to axis of rotation? Answer is yes. Okay, so let's see now. Simple thing, can add it. This is 2 kg into 0.1 square plus 0.5 kg. 0.5 kg means half kg. So half kg into 0.5 square. Simple calculation. Okay, this I can write as 1 by 10. 1 by 10 square means 1 by 100. So this is 2 by 100 actually. Plus this also 5 by 10. So you can write 25 by 100. Okay. So now what we can do, what will be the answer? Now if we calculate, answer is 29 by 100. Answer is 29 by 100 or 0.29 kg meter square. Simplest of question. Right? Let's move on to the next question now. Okay, next question. The next question, let's say 4 particles are there. Okay? They are kept the vertex of a square. They are kept on the vertex of a square. Okay? Let's say each one is having mass m. These are 4 particles which are kept on the vertex of a square. Each one is having mass m. Okay? And what is the side of square? A. Now, I want to find moment of inertia. Now the question is, where is the axis about rotation? Which axis of rotation we have to take? Okay, so I'll say that first axis of rotation is here at the center. At the center we'll find. Okay. Fine, no problem. So first of all, let's find out what this distance is. I hope you know that. This is a diagonal. This is A, so this will be root 2A, Pythagoras theorem. Okay? This is hypotenuse of right angle triangle, you can see A. So this will be root over A square plus A square, 2A square. Will come A root 2. But this is half of that. A root 2 by 2 means A by root 2. This all you need to remember always. Okay, so what will be moment of inertia? Moment of inertia m A by root 2 whole square. For this particle. For this particle also m A by root 2 whole square. For this also m A by root 2 whole whole square. For this also m a by root 2 whole square. That means I should multiply 4 here. M a square by 2 into 4. Our answer is 2m a square. I about center. Okay, but if suppose I would have asked you, let's find out about this point. Then, but okay, what will be the moment of inertia of this mass about this axis? 0, because r is 0. R is 0. So about this axis, moment of inertia of this mass is 0. So whose moment of inertia we will find? This mass, and this mass. And suppose that this point is A. So I am writing moment of inertia about A, this shape. This mass, m into A square. This mass, m into A square. Now this mass, what is the distance between this and this? This is the diagonal, root 2a. So plus m root 2a whole square. What are we getting? Ma square plus ma square is 2ma square plus m into 2a square. That is 2ma square here also. So here answer is different. This is 4ma square. So that means it says that if the masses are farther, if the masses are away from the axis of rotation, moment of inertia is more. More is moment of inertia. Why? Because I is mr square. If r is more, I will be more. Yes or no? So if the mass is far, its moment of inertia will be more. Right? Now, few more we can say. Suppose that I ask you about this axis, which is passing through this side. I am saying this is PQ, let's say. We want to find moment of inertia about PQ. What is its answer? Let's see. So moment of inertia about PQ. Now this axis is there. This is passing through the center. Right? It is passing through the center itself. So what is the radius of that? 0. Here also it is passing through the center. So its radius is 0. So whose moment of inertia we have to find? This mass and this mass. Okay? This mass and this mass. So for this mass, m into a whole square. For this mass also, m into a whole square. So IPQ is what? 2m a square. Right? So this is how we are trying to, or we find moment of inertia. But the important aspect of this is about every axis. Moment of inertia is different. Here different, here different, about this is different. If I would have told you about diagonal, then it would have come different. If diagonal is there, we know that its moment of inertia is moment of inertia 0. Then its moment of inertia m a by root 2 whole square, that is ma square by 2. This one also m a by root 2 whole square, that is ma square by 2. So total will come ma square. About diagonal, its moment of inertia will be, suppose diagonal I say is mn. So Imn will be ma square only. So moment of inertia about every axis is different. Right? Okay. Then let's do one more question. All this you have to find, okay, you have to learn. Okay, let's do a triangle question. Similar, very similar. Okay, so 3 particles I am keeping on the vertex of triangle. Let's say this is also equilateral triangle. Right? This is equilateral triangle. And let's say that moment of inertia about this axis, which is passing like this. It's very simple. So let's say this is AB. So what about this mass? All are M, okay? When I am trying to find IAB, now this axis is passing through this mass. So moment of inertia of this mass about this axis is 0. What about this one? This is at A by 2. This is also A by 2. So moment of inertia of this mass we can say m a by 2 whole square. This also ma by 2 whole square. So then multiply it with 2. What are we getting? Ma square by 4 into 2. That is ma square by 2. Right. Suppose I would have told that this is moment of inertia. This is PQ. What will be IPQ? For IPQ, its moment of inertia 0. Its moment of inertia 0. You will have only for this mass. What is the height? We have to find. I have told you this before. Equilateral triangle means 60 degrees. This is A. So this will be A sin 60. A sin 60 means A root 3 by 2. So what will be moment of inertia about this axis? M into the root 3a by 2 whole square. So what are we getting? 3ma square by 2. Right? These kinds of questions are asked in NEET exam. So easy. But you need to know how to do, then only you can get the marks, right? So this is moment of inertia, okay, for discrete particles. That means every particle is located separately, right? But if suppose, like this system is not there, a rigid body system is there, then what will you do? Then how will you find moment of inertia? Rigid body means uniform body. Uniform body means like a rod, okay? Moment of inertia for uniform bodies, uniform objects. Like rod. Okay, so there are actually derivations are involved. I'm not going into derivation. I'll give you the formula as I did in the case of center of mass. I'll give you the formula how to calculate, but we will not calculate it. A lot of time is actually required for calculation purpose. It's not asked. How to use that, that is important for us. Okay, that will be done. So first let's say rod. So rod is there. Okay, total mass is m. Where is the mass? Along its length. Linear mass density, lambda. Lambda is mass by length. Remember? Okay? Remember that. I'm not going to use it. Don't worry. Now, where shall we take axis? Let's say axis is passing through its end. And whatever I am telling you right now, you all have to remember all these. These are actually the formulas. Very, very important formulas which will be used. So we have to mug it up. No doubt about that. The more you practice, it will be automatically there in your mind. Okay? So this is axis. Okay. Now this is uniform body. Uniform body means what? Infinite point masses. So then what we have to do? We have to find moment of inertia of each individual one and then you have to add. That means integration you have to do. So the formula is here in moment of inertia. We say that take a small particle dm. Suppose here you have taken. Okay. Suppose you have taken a plate distance x from the axis and its length is dx. So we will be writing it as dm, mass, its distance from the axis is x. So this is x square. This is the formula. dm x square. From where to where we have to integrate? From where to where you will be getting these particles? From this end to that end there. That means from 0 to L. And dm is what? If you remember exactly what we did in the case of center of mass, then dm you can write immediately as m by L dx. M by L dx. You go back and check how we have done it. M by L dx. And then when you integrate it, answer will come. And that answer is important for me because I have to remember that. That is ml square by 3. Moment of inertia brought about the axis passing through its end is ml square by 12. You have to remember. There is no alternative. Okay? Fine. But if suppose this axis would have passed from somewhere else, not somewhere else, about the center. About the center. IC value. This is also you have to remember. IC value is ml square by 12. IC value is ml square by 12. About the end, ml square by 3. About the center, ml square by 12. Is it important? Yes, very important. Right? We have to remember. Alright. So based on the rod itself, let's see what kind of questions are asked from us. Okay? So see that. First question, the simplest one. This is the rod. Mass is L, length is L, and we have to find moment of inertia about this axis. Okay? From here, this distance is D. This is axis. Let's say this is PQ. Okay? Now, is this axis passing through one of the end of the rod? No. Is it passing through the center of the rod? No. Then from where it's passing? It's passing from somewhere outside. Is entire rod is at equidistance from this axis? It's said yes. Is total mass at equidistance from this axis? It's said yes. So then nothing is there. I will be I over PQ is actually m into d square. That's all. From axis, what is the distance of the total mass? Every particle is at distance d. So just write in d square. That's it. It's over. Right? Is that clear? Fine. Then, what next we can do? Okay, we'll do that. So again, I am taking one square, and this time square is made from the rods. Okay? The square. Each one is rod basically of mass m and length L. This is also mass m length L. This is also mass m length. This is also mass m length. Okay. Now I say that we have to find moment of inertia about one of the rod. Let's say I want to find about this. Say this is E. We have to find moment of inertia about E. Okay, now this axis actually is passing through this rod itself. So its moment of inertia about this axis is 0, gone. So I am not finding this one. Then, what about this rod? This axis is passing through its end. So for this one, it is ml square by 3, right? Ml square by 3. What about this rod? Here also the same, it's passing through one of its end, so it's ml square by 3. What about this rod? From this rod, this axis is at equidistance, that means a distance L. Is entire rod at distance L from this axis? Said yes. So then moment of inertia for this one is ml square, because this is L plus ml square. What are we getting? This is 2ml square by 3 plus ml square, so that is 5ml square by 3. This 5 ml square by 3. Okay. Another one we'll find. Now suppose the axis is passing through the center like this. Okay. And let's say this is Mn. Passing through the center. Okay. Then what is the moment of inertia? Fine. So this axis is passing through this rod at the center. So for this one is ml square by 12. For this also identical, ml square by 12. So okay. So Imn. For here ml square by 12. For this ml square by 12. For this one, this distance is L by 2. So m into L by 2 whole square. What about this one? This also m into L by 2 whole square. That means here we can multiply with 2. What are we getting? ml square by 12 plus ml square by 12. 2 ml square by 12. That is ml square by 6. Here ml square by 4 into 2. ml square by 4 into 2. That means ml square by 2. What are we getting then? 4 ml square by 6. Is it correct? Yeah. So our answer is 2 by 3 ml square. Answer is 2 by 3 ml square. Fine. Again I am changing axis of rotation. Why I am doing all these questions? So that you can learn how to find it. Okay? We can make separate questions, but it's not required. In one question itself we can learn all this. Okay? That's what we are doing. In one question itself we are learning it. So suppose now axis of rotation is passing through the center like this. That means it's not like this. Like this is the axis of rotation. How? Perpendicular to the plane. Little while ago how it was? Like this. Now it's like this. Okay. So from this axis, now this is passing through center, so let's say I see. From this axis, what is the distance of this one? Say L by 2. What is the distance of this L by 2? What is the distance of this L by 2? What is the distance of this L by 2? Very simple. So IC equal to M L by 2 whole square for this rod above this axis. Okay. So how many are there? These 4 are there. So what is the answer? ml square. Right? Are you able to understand? Are you able to understand how it will rotate about this? Like this. Okay. So this is how it is. This is for rod, some of the cases we saw. Okay. Another case I will show you. In the case of rod. What is the other case? Let's see. Okay, what is the case? In this one, let's say our rod is like this. This is the rod, okay? Mass and length. And this is axis of rotation. And this is making theta degrees. So how it's trying to rotate? It's trying to rotate by making a cone like this it is. And axis is here. How it will rotate? Like this. What it will make? A cone. It is going to make a cone. It's going to rotate like this. Its moment of inertia. Again, you have to remember. Okay, I am giving you the formula. You have to remember it. So see then, here also this axis is passing through its end. And we saw that whenever it passes through end, moment of inertia is ml square by 3. Here also ml square by 3 will come. But moment of inertia total is ml square by 3 sine square. ml square by 3 is there. But along with that, sine square theta is also come. Okay? You have to remember because next question I am going to ask like that. Then, one more format is there. What is that format? I'll show you that. This is the rod. Okay? And here axis is passing through its center. And this is theta. This is theta. Mass is m, length is l, everything is same. Now what is moment of inertia about this axis? Same way it's passing through center. So ml square by 12 we saw the formula. Here also it is I equal to ml square by 12 sine square. Both are very important. You need to remember that. There's no doubt about that. You have to remember that. Okay, this is also for the rod. Whatever we have seen so far, uniform bodies, only we have discussed about rod. Okay, let's solve a question involving this concept also. Okay. Alright. So I am making one triangle with these rods. Okay, there is a triangle. Same equilateral triangle. ML, ML, ML. And axis of rotation is this. We have to find moment of inertia. This is very simple. Okay. So this angle is 1. This is 30 degrees. Why? It's equilateral triangle. This is 30. This is 30. So see, then I am writing moment of inertia. Okay, let's say this is mm. So I mm. This rod ml square by 3 sine square theta, because this is passing through its end. Okay, so ml square by 3 sine square theta, sine square theta for this rod. What about this rod? Exactly same, into 2 plus this rod. This axis is passing through the center of this and it's perpendicular, so ml square by 12 directly. If suppose you want to go with the same formula, ml square by 12 sine square theta, then here angle is 90, so ml square by 12 only will come. Okay, so ml square by 12. What is the answer? Ml square by 3 sine 30 means 1 by 2, sine square 30 means 1 by 4 into 2 plus ml square by 12. So this is 2 ml square by 12 plus ml square by 12, that is 3 ml square by 12, that is ml square by 4. That is ml square by 4. Is that clear? Okay, let's see one more question. This rod question, one more question. After that, we are going to see other uniform objects, right? And other uniform objects, I won't be giving you that many questions. So don't worry, maximum questions are on rod. Okay, so let's see. Another question that I have for you is, rod is like this. Okay. It's like this. Okay, let's take them, both of them are of the same mass and length. Okay, now where is the axis of rotation? About what we have to find moment of inertia. Let's say our axis of rotation passing through this point and it's perpendicular to that. Not like this, it's like this. Can you find it right now? I think no. I need to tell you perpendicular axis theorem, after that you can find it. So okay, let's stop it right from here. When I tell you the perpendicular axis theorem, then you will solve this question. Okay? Alright. So rod we have studied. Rod's moment of inertia we found. Now let's talk about some other bodies, symmetrical bodies. Symmetrical bodies means if I say ring. Ring is like this. Its radius is r. And let's say axis is passing through the center. When I am writing cross, or if I write dot, that means axis is perpendicular to the plane. Okay? How is axis? Perpendicular to the plane, like this. You can see this tip, black. It's either coming towards you or going away from you. That is the meaning. Going away from you means cross. Coming towards you means dot. So cross is here. Now you see that this is a ring. So where is the mass? On the ring, obviously. Is each particle of this ring, is it same distance r away from the axis? Yeah, every particle of the ring is a distance r from the disk. So what will be moment of inertia? Every particle dmr square, dmr square, dmr square, dmr square. That means moment of inertia mr square. What is M? M is the total mass of the drum. So moment of inertia of the disk is mr square. Do we have to remember? Yes. We have to remember. Okay? It's a disk. Disk also similar actually. It's like this. Right? Mass is M. The radius is R. What about this moment of inertia about the center again, passing through the center and perpendicular to the plane? What will be moment of inertia? Say mr square by 2. Mr square by 2. Okay, now based on these two only, I am going to ask you questions. Suppose, now for this one, moment of inertia about this point is mr square. Understand? Now, suppose I have half of the ring. Okay, not this one. I have another one. It's half of the ring. But its mass is also m. Radius is r. And we have to find moment of inertia for this. Now, what will be moment of inertia? Axis is over here. Particles are on the ring. What will be its moment of inertia? mr square. Why? Because every particle is a distance r from the axis of rotation. So okay, fine. But if suppose that I have quarter of the ring, then quarter of the ring means like this. Okay? This is a quarter of the ring. And axis is again like this. Mass is m. Okay? Mass is m only, radius is r. Now its moment of inertia. Its moment of inertia is also mr square. Provided masses are m only, okay? But if suppose I say I cut a portion of this. I am cutting a portion of this from here. Okay? And the portion is like this. This is the portion. From this I have cut this portion. And this angle is 60 degrees. The radius thrown out is r. What is its moment of inertia about this axis? Then how its mass is not m definitely because you have cut it from here. Entire ring's mass is m. What will be mass of this? We have to find. So here in this ring, what is the angle subtended at the center? 360 degree. So for 360 degree your mass is m. For 60 degree what will be the mass? m by 6. Are you able to understand? For 360 degree, mass is m. For 60 degree, what is the mass? How to do 360 degree mass is m. For 1 degree, m by 360. So for 60 degree, m by 360 into 60. M by 6. So here its mass will become m by 6. So moment of inertia will become m by 6 r square. I hope you understood that. Okay? I hope you understood. Let's go for the disk. Okay? In this also similarly, if suppose that half of the disk we are getting, but if its mass is m, okay? Full disk moment of inertia about the axis passing through center is mr square. Now I got half of the disk. Moment of inertia we have to find about the axis passing through center, and its mass is m. And radius is r. Then what is moment of inertia about this? It's mr square by 2. Same. Reason its mass is same as its mass. If it's a quarter of the disk, then even then it will be mr square by 2, provided quarter's mass is m. Okay? Remember that. But if suppose that from this disk only I am taking a part, like in the end I told you in the case of ring, if from here only I am taking a part, only this part I am taking, let's say 90 degree. So 90 degree part's mass will be what? M by 4. Remember that. This is disk. Your this is the axis. So moment of inertia basically is what? M r square by 2. But what is M? M by 4. R square by 2. Moment of inertia M r square by 8. This is how we need to calculate. Okay, depending on what the mass is there. Very necessary for us to know what is the mass. Without that we cannot. Okay? Ring and the disk. Okay? Then we are going for next is a sphere. Okay, two types of sphere are there, hollow sphere and solid sphere. So hollow sphere. About an axis which is passing through its center. Its mass is m. Radius is r. Now this is passing through center, or this is passing through center, or this is passing through center. Okay, any of the axes which is passing through center, whether it's x-axis, y-axis, or z-axis, all are basically the diameter of that sphere, because it's three-dimensional body and symmetrical body. Okay, so moment of inertia about any of the axes will be same. Okay, and what is that? That moment of inertia that you have to remember, that is 2 by 3 m square. Yeah, remember. For hollow sphere, when axis is passing through the center, whether it's x, y, or z axis, moment of inertia is 2 by 3 m square. Right? If it's a solid sphere, let's change all into solid. Solid sphere. Then moment of inertia, little change. Everything else is same. X, Y, Z, everything is same. But this is not 2 by 3 m square. It's 2 by 5 m square. Right? It's a 2 by 5 m square. Understood that? Is it good? Then what more we have? We'll be going for cylinder. Okay, hollow cylinder. Hollow cylinder. This is hollow cylinder. About an axis which is passing through its center. Hollow cylinder. Now this hollow cylinder, can I say, is basically a ring, a thick ring. A thick ring. Its mass is m, radius is r. It's a thick ring. Ring was there, whose thickness we normally don't take. But here I am saying it's a ring only, but its thickness, like normally two types of rings you must have seen when you go to the jewelry shop. Okay, one will be very thin ring, you put it inside finger. One will be thick ring, slightly thick, not this much thick, but still. That is also a ring. So this is similar thing. So if it is a ring and axis is passing through its center, then moment of inertia will be m r square. No need to worry, because we are saying it is a ring. Same way, suppose it's a solid cylinder, I will call this as what? Disc. Okay, thick disc. Solid cylinder. Right, moment of inertia passing through this is m, this is r. Then moment of inertia, well, this is m r square, right? Cylinder. Then next one, cone. Cone. Two types of cone again. Hollow cone, solid cone. Hollow cone means what? The one in which we take ice cream, right? Must have seen the ice cream, that one cone they will give, and then they will fill the cream in it, and then we add. That's cone. Which cone? Hollow cone. Let's see hollow cone. Moment of inertia. These all you have to remember. Okay. This is hollow cone. This is hollow cone. Okay, for ice cream actually it will be inverted. Okay. So this is R. Mass is R. Its moment of inertia, same like disk, mr square by 2. Do we have to remember? Yes. Solid cone. If this is a solid one, a solid cone, the same diagram I am making. Okay, I am not making another diagram for that. A solid cone about this axis only, moment of inertia, solid cone. Okay, it's 3 by 10 mr square. 3 by 10 mr square. Okay. That's it for the time being. These are the moment of inertia we have to remember. Okay. One more question is coming in my mind that we will remember. That is related to cavity. In the previous chapter in center of mass we found if there is a cavity, then how to find center of mass. Here also, if there is a cavity, how to find moment of inertia. That also we should learn. Okay. So see, there are few more moment of inertia that I will tell you after telling the perpendicular axis and parallel axis thing. Okay. So, what is the question? Question is, I have a disk. Okay, I have a disk now. And in this disk is of radius, let's say capital R. From this disk, I removed a portion. This portion I removed. The radius is R. So now only this portion you have. Okay? This portion only you have. Find the moment of inertia of this portion, which is remaining with you. Which is remaining with you. Axis is passing through the center. Right? So if you remember how we found in case of center of mass, same thing. What? First we are going to consider that there is an entire body of radius R. And then from it, this body. So this is capital R. And this body is removed. So I will find moment of inertia of this entirely about this axis. And then I will subtract moment of inertia of this about this axis. That's all. So problem here is what? Problem is only mass. So let's assume that it has a density, as we did in the case of center of mass. Which density will take this plate, this surface density, sigma. Sigma is here. Okay, so moment of inertia of this I am writing, I1. I1 is what? mr square by 2. What is n? Sigma into area. So sigma into area by r square. This is mass, okay? Into r square by 2. Very simple. Mass also I can give in this one. Mass also can be given in this. But we are not taking. Okay? If you want to take mass, there is a possibility it will be given. Okay. Take mass of this only. This portion's mass is n. Okay. But first you see that what it is, then I will tell you how to put that. I2 for this. I2 is sigma pi r square into r square. So total moment of inertia will be what? I1 minus I2. What is common in this? Sigma and pi is common. And this 2 is common. Sigma pi by 2 r square minus r square. This is actually answer in terms of sigma. But if mass m is given, then what will you do? See, sigma basically is what? Mass by area. Right? Whose mass is m? This portion's mass is m. That's all, because this is not included in that. So this portion's mass is given. So sigma will be this mass by its area. What is its area? Sigma is m by pi r square minus r square. This is sigma. then I can write it. Right? This we can write over here because that is only the area. It's pi r square is this is r square. You can put it this way. We'll get the answer. Are you able to understand? Is that clear to you? I think I have. Okay. This is r to the power 4, and this is also r. So if I am going to keep sigma over here, m by pi e r square minus r square into pi by 2. And this r to the power 4 minus r to the power 4 I can write as r square square minus r square square. That means we can write that as a square minus b square. A square minus b square we can write as a minus b into a plus b. That's pi and pi gets cancelled. Okay. So m by 2 r square minus r square. Here I am writing r square minus r square, that is a square minus b square means a minus b, a plus b. What is a over here? R square is a, and this r square is b. So a minus b I have written, then a plus b. So this and this gets cancelled. So your answer is m by 2 r square plus r square. This is momentum equation. Okay? That's all for today. In the next class, we'll learn and we'll finish momentum inertia. Okay? But for you people, practice is very necessary because it's important. Every year in NEET, 5 to 7 questions comes from this topic. Okay? So please keep practicing this one. Okay? Bye for now.